Hi guys, welcome to lesson 29.2, adding and subtracting rational expressions. This is going to be day 1 of 2. Okay, so today we will identify excluded values or restrictions of rational expressions, and then we will also add and subtract rational expressions. You should be able to find the lesson 29.2 note sheet posted on Google Classroom. You'll want a pen or a pencil, and you will want a calculator. All right, so adding and subtracting rational expressions is very similar to adding and subtracting normal fractions, like what we were doing in class. So in order to add the two fractions, we must get a common denominator. So that's what you want to know. A common denominator, just like with regular fractions. Okay, so example A here says adding and subtracting with like denominators. So if you'll notice here, simplify the expression 2x over x plus y plus 2y over x plus y. Well, they have common denominators. The denominators look exactly the same. So that's why these are called like denominators, because they look alike, right? So your first step is going to be to find the common denominator, but that was already done. It is x plus y. Your second step is going to be to add the like fractions to find the solution. So you would literally just add what's on top here. So this 2x plus 2y, so that's what they did here. And then you would put it over the common denominator, okay? Now in this case, it does say to simplify as if possible, so you could take out a GCF of 2, and you'd be left with x plus y. So then the x plus y's would cancel to leave you with just 2. But sometimes you won't be able to simplify, and in that case, that would be your final answer, okay? But if you can simplify, you always should, okay? All right. So let's go ahead and try a few examples here. So it says to simplify each and state any restrictions on x. Remember from what we were doing before spring break that restrictions are your excluded values, and those come from the denominator. So actually, we could just go ahead and start with that. So looking at your denominators here, we have an x plus 2 and an x plus 2. So those are already common denominators or like denominators, so we're good. But let's go ahead and right away set that equal to 0 so that we know what the restrictions are. Okay, so I would set x plus 2 equal to 0. I would subtract the 2 over. And so I know that x cannot equal -2. Because if we were to plug in -2 to the denominator, we would get 0, and that would be undefined. Okay, so we know that is our restriction. But again, because we have these like denominators, all we really need to do is add the numerators. So I could write that as 3x plus 6 all over, you just need to write the denominator once now, so over x plus 2. Okay. Now remember, step 3 was to simplify if possible. So I can take out a 3 as a GCF in the numerator, and that's going to leave me with x plus 2. And then remember, it's written over x plus 2, and those can cancel. An x plus 2 over an x plus 2. So your final answer would be just that 3, and you would say x cannot equal -2. And that would be your final answer. Okay. All right, let's go ahead and try this other one here, part B. So again, we have this x squared minus 9 and x squared minus 9. So we're good to go. We have common denominators. But what we need to do here is let's go ahead and factor that. So remember, x squared minus 9, that's a difference of 2 squares. So remember, that can be written as x plus 3, x minus 3. Okay, so that is going to be your new denominator, if you could write it that way. And so if we want to come up with our restrictions, we would say, Okay, if we set x plus 3 equal to 0, we know x cannot equal -3. And if we set x minus 3 equal to 0, we know x cannot equal +3. Okay. So now let's go ahead, and this one is asking for subtraction. So let's go ahead and subtract on the top here. So x minus, there are no other x values. And then -1 minus 2. Well, -1 minus 2 is going to be a -3. Okay, so x minus 3 is on top. And then let's rewrite this x squared minus 9 as x plus 3x minus 3, the most factored version. And so when we do that, again, we're going to have some cancellation. So these x minus 3's will cancel. So remember, if everything cancels on the top, we can still say that there's a 1 there. So we would say that this is 1 over x plus 3 as our final answer, where x cannot equal 3, -3 or 3. And that would be your final answer here. Okay, so be careful with those, but those ones should be a little bit easier because, again, they have a common denominator already. Okay, let's keep moving here. Another example B, is finding the least common denominator now when they do not already have the same denominator. Okay, so if you look at this example, we have 1 over x squared minus 3x minus 4 and 1 over x squared minus 16. And they're asking you to find the least common denominator. So what you're going to want to do is factor each denominator, which they did here. So we have x plus 1, x minus 4, and we have x plus 4, x minus 4. Okay. So you're going to want to identify the factors that are in common. So this x minus 4 is in common, and we're only going to write that once. So that becomes part of your least common denominator. But then you also want to identify the factors that are not in common, which would be this x plus 1 and this x plus 4. And those also become part of your least common denominator. Okay, so that's really important to notice there, is that basically you just don't rewrite any of your common denominators or factors in common, but you do write all of your factors not in common. Okay, so let's try another one here. So again, first thing you would do is factor. So I would take out an x here, factor the denominators, and I would be left with x minus 6. Then in this one, I would go ahead and factor the trinomial. So what two numbers multiply to -18 that add to -3, a -6, and a +3? So those would be written as x minus 6 and x plus 3. Again, you want to first discover which denominators or which factors are in common. So this is in common with this, meaning they're the exact same. So part of my LCD, my lowest common denominator, is going to be x minus 6. Okay, then what is not in common? Well, we have this x and we have this x plus 3. Now that just looks a little bit funny to me, so I would probably put the x out front, then x minus 6, then x plus 3. But either way, means the same thing. That would be your least common denominator. Okay, this is going to be important for our day 2 when we have to find common denominators in order to add or subtract. Okay, so let's go ahead. That's what we're going to be doing tomorrow as part of our video, but I want you guys to go ahead and try this one here. So find the least common denominator. And in this one, we have a 2 and we have 5x plus 3. The first thing you should be doing is trying to factor, but actually neither of these are factorable. So what you would do is just, there's nothing in common, so we would write them both out. Okay, there's nothing in common, but these are not in common, so we have to write them both. So that is your least common denominator, 2 times 5x plus 3. Okay. But if we try another one like this, okay, so you have x plus 2 as one denominator and x squared minus 4 is the other. So x plus 2 is already factored. That one's good to go. X squared minus 4, that's a difference of 2 squares. So we can write that as x plus 2, x minus 2. Again, remember, in order to find your least common denominator, you look at your factors and whatever they have in common, you're going to write once. So that x plus 2 is part of it. And then whatever they have not in common, you're also going to write once, which would be this x minus 2. So the least common denominator is x plus 2 times x minus 2. Okay. And again, that's going to be a really important skill for what we do tomorrow, which is going to be adding and subtracting rational expressions that do not have the same denominator already. Okay, like the ones in the beginning of this video. All right. So if you have any questions, go ahead and leave them here or bring them to class tomorrow, and have a wonderful day. Bye-bye.